Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We're going to look at our final three-dimensional object today. We're going to look at the cylinder. What's not to love about a cylinder? It contains soup and pasta and all the fun things we like to eat. What I showed you in class on Teams, of course, is that when you take a cylinder and lay it down until it's two-dimensional shapes, the net of that cylinder is two circles and a rectangle. So if we want to calculate the surface area of this cylinder, we have to calculate the surface area of the rectangular piece and the surface area of the two circles. Now, there's a couple steps in there that we require to do to have to get the dimensions of the rectangular piece. So that's going to be the tricky part, is playing around with the rectangle. The circles are actually pretty easy. Now, to calculate the surface area of the cylinder, we want to find the area of the circle and double it, because there's two circles on a cylinder, right? And then we also have to find the area of the rectangle. One of the dimensions of the rectangle is the height of the cylinder. The other dimension is the circumference of the circular bases. So I tried to demonstrate this on Teams. It's a little bit harder to show in this video, but I'll do my best. Let's find some surface areas of cylinders. So it says, calculate the surface area of the cylinder. Now what we need to picture is unrolling the cylinder to get the rectangular part. It's the rectangle I want to talk about first. So when we unroll the can part of the cylinder, we get a rectangle, right? A rectangle that looks something like this. So if we unrolled it, we get a rectangle that looks something like that. All right. Now, one of the dimensions of this rectangle is pretty easy. The height of the cylinder is the shorter side of the rectangle. So the height of the cylinder is the shorter side of the rectangle. So that side on the rectangle will be 15 centimeters. But it's the longer side that's the issue. Now, when we unrolled this cylinder, this was the length. The long part of the rectangle is this part right here that got unrolled, right? When you unroll it, the unrolling of the cylinder gets this long side of the rectangle. Now, we know from a couple days ago that distance that I'm circling right now is the circumference. When we unroll the cylinder to get the rectangle, this distance is the same as this distance on the rectangle. So to figure out this distance, we have to calculate the circumference of the circle. So we have a math equation for that. We have that C equals pi times diameter. So we can do that calculation, and that will give us the long part of the rectangle. So we'll do C equals 3.14 multiplied by the diameter of the circle. Now, in this circle, we have been given that the radius is 5 centimeters. That means the diameter of this circle will be 10. So the diameter is 10. We multiply that, and we get the circumference of the circle is 31.4 centimeters. So that means we've just figured out the distance around that circle is 31.4 centimeters, and that distance is the long side of the rectangle. So we would say the length of this rectangle is 31.4 centimeters. Now we have the ability to calculate the area of this rectangle. So let's go and calculate all the parts of this cylinder now to get the total surface area. So I'm going to go to this page, and let's calculate the rectangle first. So I'll write rectangle. And we know the area of a rectangle is area equals length times width. So our rectangle we've determined has length 31.4 centimeters, width 15 centimeters. So I'm going to do area equals 31.4 times 15, the dimensions of that rectangle. And when I work that out, 31.4 times 15. I get that the area of the rectangular part is 471 centimeters squared. So that's the area of the rectangular part, the part that we unrolled. Now, we also have in this cylinder, we have two circles. We have one on the top, and we don't see it, but there's one on the bottom, right? Like that. So we need to calculate the area of those two circles. So all we need to do is calculate the area of one of the circles and double it. So I'm going to write circles right here. And we know the math equation to calculate area of a circle is area equals pi times the radius squared. Substitute in our numbers, area equals 3.14 multiplied by the radius squared. Now the radius of the circular part of this cylinder was 5 centimeters. So we'll do 5 squared. We actually did that exact area in class yesterday. That's area equals 3.14 times 25. And when we work that out, 3.14 times 25, we get 78.5. But that's not our final calculation. That's just the area of one of the circles. And we have two circles that are exactly the same. So let's double this to get the area of both circles. The area doubled is 157 centimeters squared. That's the area of the circles. Now, to get the total, take the area of the rectangular part, 471, add the area of the circles, and you'll get your total area. 8, 7 and 5 is 12, carry the 1, 628 centimeters squared. That's how much total material would cover the exterior of this cylinder. So if you needed to paint the cylinder, that would tell you how much paint. You know, this is centimeters, it's very small. But that would tell you the total surface of the cylinder. Now, again, if you didn't want to know the whole thing, you could just calculate the area of the rectangular part or the area of the circular part. But that's how you calculate the area of a cylinder. You find the area of the rectangular part, and to do the rectangular part, you have to calculate the long side by getting the circumference, and then you do the area of the circles, and then you add them up, and you get a total. Now I'm going to do a couple more examples of this in my next video, but that's the basics of calculating the area, surface area of a cylinder. I hope that helps. That's all for now. Flexing Teacher Weber, out.